So the end of 6.4 is more of the shifting that we've done a bunch this semester. I think this is the last time we do shifting. So each of the functions gives me a seed function, and for 72 to 83, I'm starting with the function y, or f of x, equals the log base 2 of x, and it's graphed here. The points aren't that boldly marked, but they're there. And I'm going to do a couple things. In part A, I'm going to find the requested function. In 72a, I'm supposed to find f of x plus 2. And to find f of x plus 2, I just change the x to x plus 2. Because there's a parentheses and the x plus 2 is in the parentheses, it needs to stay in the parentheses. I can do part C quickly before I do the domain. Not with that sheet, I can't do it. With this sheet that hopefully you're starting to know right now, plus is inside a parentheses, move the graph left. So this graph is going to be moved left too. And to find the domain of any logarithmic function, you take the argument and set it equal to 0. So for part C, I'm going to take the argument of x plus 2, set it equal to 0 by subtracting 2 from both sides, and get x is greater than negative 2. And as an interval, that's starting at negative 2 and going to infinity. Round brackets on everything, because your logarithms have a vertical asymptote that they never touch the graphs. So to create my graph, I'm going to draw a vertical asymptote at negative 2 on the x-axis. So I found negative 2 on the x-axis. Draw my vertical asymptote. Now each point that's marked, I'm just going to drag it over 2 to the left. So this point that's here, I'm going to go 1, 2 to the left. This point, 1, 2 to the left. This point, 1, 2 to the left. This point, 1, 2 to the left. 1, 2 to the left. 1, 2 to the left. And I'm going to connect the points, make sure they get really tight to that vertical asymptote in my graph, but it doesn't actually cross nor touch that vertical asymptote. And that's about as good as I can do. That is not the nicest bend I could have. The bend should look just like that bend, as opposed to the bend that I put in this graph. Not such a big deal. So all I've done is just taken each point that's marked, moved it over left 2. You're going to have to print this graph out to physically do the moving and to see it better than you might see it on the screen right now. On the test, I'll give you a graph. And so as you're doing the homework, you don't want to print out a graph to move it, just as long as if you understand what you're going to need to do on the test and you could do it, fine by me. I don't have any, I'm not going to worry about you not wasting ink to graph this. A lot of you won't even have a printer to do this. I had to buy a printer for this semester because I can't go into school. Usually I do all my printing at school. So 75 gives me the same seed function as does 74. For 74 part A, to find the requested function, I'm just going to put the x minus 3 in the parentheses where I forgot the 2 here. And I'm going to get f of x minus 3 equals the log base 2 of x minus 3. Minuses in parentheses. Shift the graph right, so I'm going to say the graph is shifted to the right for part C. It's going to go right 3. For part B, to find the domain, I'm just going to go x minus 3 is greater than 0. I'm going to add 3 to both sides and get x is greater than 3. And the interval notation for that is 3 to infinity. That means that's where the vertical asymptote is going to be on this graph. So on this graph, I'm going to find 3 on the x-axis. I'm going to, the best I can, draw a vertical asymptote through 3. I'm going to take each point and move it 3 to the right. And this is confusing. This 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. These points are just going to be right on the other side of the axis. It's going to look something like this. I think I'm going to dispense with graphing. I'm struggling with my poor seed graph. It's just not dark enough. I use Desmos as opposed to my other program to create this graph because it makes some things about it are nicer, but boy, it's so light it's probably really hard for you to see. So you can just imagine taking every point that's on the graph, dragging it over 3 units, and then drawing the same shape, getting the vertical asymptote at the start of the domain. So maybe I'll say let's disband with the graphing. Maybe I don't know if I'll even graph this one. How many more do we have? We just have like 4 more. So find the requested function for part 70, question 76. The seed function for all of these is the log base 2 of x. For part A in 76, to find f of x plus 1, I'm going to add 1 after the parentheses, not inside the parentheses. And what that has the impact of doing is it shifts the graph up. So for part C, it's going to move the graph up 1. Since it's not moving it left or right, it's not going to change the domain. To find part C, to find the domain, you just take the argument, in this case it's just x, and set it greater than 0. This is going to have the same vertical asymptote. Shifting a graph up and down doesn't change the vertical asymptote, only shifting a graph left and right. So for this graph, I'm just going to make each point go up 1. That's kind of easier for me to do than the left and right with the graph that I'm starting with is not so easy for me to do. So each point, just drag it up 1, and it looks like it's 2 boxes for 1. So this goes up 2 boxes, which is equal to 1. That goes up 1. That goes up 1. This goes up 1. That goes up 1. That goes up 1. I get the same vertical asymptote. Eventually the graphs kind of just come almost right on top of each other because of the width of my marker. And that's just taking each point, dragging it up perfectly 1. 78 is going to shift down. Anyway, 78 starts off with the seed function f of x equals the log base 2 of x. And in 78a, it asks me to find f of x minus 1 because that minus isn't in a parentheses. It goes after the function. Because it's not in a parentheses and it's after, the minus moves the graph down. The domain, the argument hasn't changed. The domain is going to stay 0 to infinity. Always, if I want to find the domain, I take whatever the argument it is, and since it hasn't changed, the domain's not going to change. It's still going to be x greater than 0. I'm going to get a vertical asymptote on the y-axis, and then I'm just going to take every point and bring it down 1. So that point down 1, that point down 1, that point, this point, that point, and that point. So it's going to look remarkably the same, just drawn down 1. And as I get close to the asymptote, you can't really see that down so much because the y's start to jumble up on each other. That's a reasonable graph. Let's do 81 together because I never ask y-axis shifting and we should be able to do it. So 81, find the requested function. So we're going to do 81 and not 80. And the domain is going to be weird. So I'll show you here in a second what's going to happen when I flip it over the y-axis. It's actually a hard domain. So it's a good one to be doing. So the seed function for problem 81 is f of x equals the log base 2 of x. To find f of negative x, it's going to be the log base 2 of negative x. Ugh. How do I find the domain? I take the new argument and set it bigger than 0. This new argument is really negative 1x, and I'm setting that bigger than 0. When I set that bigger than 0, I need to divide both sides by negative 1. And when I divide both sides by negative 1, I have to flip the inequality. We did that a little earlier this semester. I get x is less than 0. That means 0 is the end of my domain, and my domain starts at the furthest I can get away to the left of 0 at negative infinity. The domain actually gets flip-flopped. Wouldn't put this on a test, but it's nice. It's a good problem. And the reason the domain gets flip-flopped is because the graph gets flipped over the y-axis. F of negative x is going to flip the graph about the y-axis, so the transformation, it's going to be reflected over the y-axis, which means each point needs to go on the opposite side of the y-axis. This point 8, 3 needs to remain up 3, but it needs to be over to negative 8. And I don't know where negative 8 would be. Maybe it's about there. So that point needs to go way over here to the exact opposite side of the x-axis. This point 4, 2 needs to turn into negative 4, 2. So what I'm doing to flip a graph over the y-axis, I'm changing each of the x's. This point 2, 1 is going to go to the point negative 2, 1. This point 1, 0 is going to go to negative 1, 0. This point, 0.5, negative 1 is going to go to negative 0.5, negative 1. And this point, 0.25, negative 2 is going to go to negative 0.25, negative 2. I'm just changing every single x coordinate, leaving the y's exactly the same. And the vertical asymptote didn't change. It's going to stay at 0, but instead of approaching the graph on the right side, it's going to approach on the left side. So this graph, it's reflected over the y-axis. You get the mirrored image across the y-axis. Should look something like that. So those are supposed to be mirrored images of each other. And the domain here, the left edge of the graph is negative infinity. The graph stops at the y-axis, which has an x-coordinate of 0. That's why the domain comes out to be that. The algebra kind of confirms what the graph, the algebra confirms the graph. These stay the same thing. This says I only have graph to the left of the line of, only have graph to the left of the y-axis. One more, and this is a stretching one, and those are so hard for me to show. So in 82, I'm using the seed function f of x equals the log base 2 of x, and to find 2 times f of x, I'm going to put a 2 in front of my logarithm and get 2 times the log base 2 of x. Since the argument is just x, the domain's not going to change. To do the domain, I set the argument, in this case it's still x again, greater than 0. That's already solved for. That's still 0 to infinity. My new graph is still going to have the y-axis as its vertical asymptote. Describe the transformation. If you multiply by a number bigger than 1, it stretches the graph. So that's all I'm going to write here, is that it gets stretched. And how does it get stretched? Each point, its x remains the same, but y gets multiplied by 2. So the point that was 8, 3, it's going to turn to 8, 6. So this point's going to get bumped up. I'm going to multiply its y by 2 and leave the x the same. Points get stretched away from the x-axis. The point 4, 2, I'm going to multiply its y by 2 and get 4, 4. That's how its point gets stretched away from the y-axis. The point 2, 1, I'm going to multiply its y by 2, and it's going to get stretched to the point 2, 2. The point 1, 0, it's going to stay at 1, 0, because when I multiply the y of 0 by 2, I get 0. And these points get stretched down. The point negative 0.5 comma negative 1, it's going to go to negative 0.5, negative 2. When I multiply negative 1 by 2, I get negative 2. So this point's going to get drugged down. And the point positive 0.2, this is positive 0.5, negative 1, positive 0.5, negative 2. The point positive 0.25, negative 2, I'm going to multiply the y by negative 2 and get -4. So this point is going to get dropped straight down to there. If I try to connect these using the same asymptote, it's supposed to go through this point and then these points. It gets drug away. I don't know how great that is, but it is what it is. If I needed a more accurate graph, I would use some program to draw it. But the theory is you multiply each of the y's by 2 if you have a 2 in front of the function, and create the new points and then connect them with more or less the same shape. It's going to be distorted a little bit when you multiply, when you stretch, when you stretch the function, or it stretches or stretched or something. Stretch is fine. So that's the entire section. We have 2 sections left in this chapter. 6.5 is short, but has a bunch of new rules. 6.6 is another long section. So let's just stop for now.